I think his connection might went, but I can hear you, Chris.
Okay, Jordan, I don't know. Can you take control? I think you're gonna go first with your screen, right?
Yep, I just picked myself from the list, I guess, and
yeah. And so while Jordan's doing that, I'll introduce myself. My name is Chris Wiederspan. I work for Microsoft. I'm actually based here in Denver. My role is an Azure App Dev Specialist, so I kind of focus on the Azure Cloud through a developer lens. Generally, that translates into some of our technologies like cloud native, so Kubernetes. That's kind of what we're going to talk about today. Our platform as a service, serverless, and some of our DevOps technologies. So I'll jump back in here in a minute, but Jordan, go for it.
Yeah, thanks everybody. My name is Jordan Nelson. I work with Chris. I'm an Azure infrastructure specialist with Microsoft based out of Utah. So Chris and I work together a lot. I cover the infrastructure and he covers kind of the app dev side. So we're going to jump in. Let me just make this full screen. And does everybody see the slides okay? Chris, you see it? Everybody else see it?
Yep, I think you're good to go.
Okay, cool. All right, well, we're going to discuss Azure Arc enabled Kubernetes, or Arc for Kubernetes. If you're, I might not muted there, but so before we get into all the Kubernetes components of Azure Arc, you're probably wondering what Azure Arc is. So we're going to take just a minute to talk about Azure Arc. If you were on any of the Ignite sessions, there was a lot of talks on Azure Arc. So let's get into that. Let me just close. Oops, I don't want to do that. I'm not quite familiar with this. I'll just move that down here. Okay. All right. So the customer, your environments today, they're getting more and more complex, right? We are seeing customers that have lots of different applications. They're running in lots of different programming languages. You're containerizing some of these workloads. Some of these are still possibly on VMs. You're now getting in, to serverless. And then there's lots of diverse infrastructure. So you have data centers, possibly multiple data centers. We're seeing customers getting devices at the edge with IoT. And then on top of that, you're probably, as a customer, in multiple cloud environments, 1, 2, or possibly 3. So lots of increased complexity. And so we think that Azure Arc and Azure can help with this. So if those that aren't familiar with Azure is definitely, we're a hybrid cloud. We were one of the first clouds to introduce hybrid. So Azure, if you're familiar obviously with the Azure public side, we've got the Azure public cloud, the Azure government cloud. We also have offerings called Azure Stack, where we run Azure inside of your data center. So you get the same APIs, same portal, same CLI with an Azure rack mounted set of hardware inside of a customer's data center. We also have Azure IoT, where we have actually edge devices that sit and are governed and managed by Azure. And then we have Azure Arc for any data center, any cloud, for everything else. And we'll get into a little what that means here in just a second. So this slide's fairly busy, but if you're familiar at all with Azure, if you're not, we'll walk through this and you will be after. So we kind of start from left to right, we have obviously our Azure customers that are coming in. They're working with the Azure portal, a CLI, possibly PowerShell if you like PowerShell, and they're interacting with what we call Azure Resource Manager. And you can think of Azure Resource Manager as the front door to Azure. And so this is where you do things like set up your subscriptions, configure your role-based access, create ARM templates to provision stuff. So what we do with Azure Arc is we extend. And Azure Arc is actually 3 things. We extend to servers, so kind of IaaS infrastructure. We extend to Kubernetes, and we also extend to data services. So think of these services that we're pulling in or possibly running across any environment, data center or other clouds, looking and feeling like it actually belongs and is living in the Azure ecosystem. So this will explain kind of the three buckets. So the first bucket is what they call Azure Arc for servers, where we can actually pull in any server from, say, GCP, AWS, on-prem data centers, and they show up in the Azure portal as though they are a managed resource that we that you can work on and operate on inside of Azure, because they're part of that Azure Resource Manager set of APIs. The second thing we can do is bring in Azure Kubernetes, or sorry, not Azure Kubernetes, any Kubernetes cluster. So we can actually bring them in, inventory that. We'll be able to use GitOps deployment and DevOps techniques against those clusters. And that's what we're going to dive into, so I won't go too much into that right here. And then the last one is we're able to run data services, our Azure data services, Azure SQL Managed Instance, Azure Postgres, PaaS offerings across any cloud environment, any environment on-prem that you want. So that's Azure Arc, three different buckets that we're pulling in and managing and using Azure as that central, think of it as that central control plane. So as we get into Azure Arc enabled, Azure Arc for Kubernetes, what are some of the features that it actually provides? So one is centralized management. We can Arc enable these clusters. We can pull them in. You can have one unified view in the Azure portal. You can see your inventory. You can see the versions of your clusters. You can do any, kind of one central, like I talked about earlier, one central control plane. We can now use GitOps to manage and configure these clusters in from a single source, have a kind of a single source of truth that you can provision these from. And then you can also leverage all the Azure management capabilities, the monitoring capabilities when these clusters are Arc enabled. So what are the features that a customer, or the steps that a customer would go through to do this? I'll walk through the steps here in a minute, but this is just kind of high level. So one, you have to have a Kubernetes cluster somewhere, and then we Arc enable that. It can be, say, a cluster enable running on Azure Stack. It can be a cluster just sitting in your data center. It can be a cluster in another cloud. We then deploy an Arc agent to that, which gets pushed via a Helm chart. Once you do that, then you're able to see that in the Azure portal, and then start monitoring and then deploying your applications, Kubernetes applications, or even just your cluster configurations to get the cluster set up via a GitOps workflow. So let me just show you, instead of popping out and doing this just with a CLI, I took some screenshots on this one. I think Chris, when I hand this over to Chris, his will be a little more demo oriented on the GitOps portion, but where this is just a few CLI commands, it was a little easier to throw this in a PowerPoint presentation. So the first thing you do is there's a few prerequisites. You need to have the Azure CLI, a certain version of the Azure CLI. You need to have Helm 3 installed on wherever you onboard these clusters. There's a few other small prerequisites that's on our site. But after I've done though and meet those prerequisites, all I do is run a simple AZ connected kdesk connect command. I give it a resource group inside of Azure that I'm going to bring the Arc enabled cluster object into. And then I give that a name of what that Arc enabled cluster is going to be inside of Azure. And once I do this, it runs through a few things. It deploys a Helm chart to the cluster. It actually looks at the local kube config for whatever cluster you are Arc enabling, deploys that Helm chart, and then you can just see that it deploys a certain set of deployments and secrets. And then at the end, you have an Arc enabled cluster. So this is showing the Azure portal. You can see down here that these clusters under the Kubernetes service at the bottom are actually just AKS clusters. If you're not familiar with AKS, it's Azure Kubernetes service. It's a managed Kubernetes cluster inside of Azure. And then these objects here are the clusters that we've Arc enabled and actually brought into Azure. And now they're actually a part of that Azure Resource Manager that I talked about earlier. So it looks and feels as though they actually are living inside of Azure. And now we can start doing some really interesting things with it. So with that, I will hand it over to Chris, and he's going to talk about the GitOps piece of Azure Arc and show you some demos. So, Chris?
Yeah, and let me just spin this up real quick. So, trying to switch presenters here real quick. Share my screen. There we are. Okay. Hopefully you guys can see this. I'm Jordan, can you see that screen okay?
Yeah, looks good.
I'm not going to do too many PowerPoints, so I'm not going to even go into slideshow mode, but I think one of the most powerful features, and this is for Kubernetes in general, but certainly Azure Arc makes it super easy and really takes advantage of it, is the idea of GitOps. And so GitOps is this notion of combining Git and operations. I mean, no rocket science there, right? So kind of from the Git standpoint, we're treating everything as source code. We're using that as the single source of truth. We can do things like pull requests, right? So as different teams may be adding or removing things from our Git repository, we can put that through a rigorous pull request routine. And that gives everybody a chance to kind of govern those changes as they come in or go out of the repository. And then from an operational side, everything's observable, right? So I can see everything in one place through the source code and through the repository, but I can then actually execute that against my Kubernetes cluster. So some of the principles or advantages of that is that everything is described declaratively, right? Everything is code in one shape or another, whether that's YAML files or Helm charts or config maps. I mean, everything's getting stored as some sort of source in my Git repository. State declaration, we're kind of keeping everything versioned in source control. That goes without saying. Approved changes, the pull requests, all that. And then ultimately everything becomes a desired state configuration machine, right? So the agents that run on the cluster, and we'll talk about this here in just a second, these agents will effectively pull my Git repository and strive to make my cluster meet the requirements outlined in the Git repository. So that's where we'll go from there. That brings up this idea of Flux, and Flux is you'll notice that a couple of these previous slides reference Weaveworks. Weaveworks is one of the companies, or the company, that kind of made some of this, or popularized some of this, the idea of GitOps for Kubernetes. They came up with this idea of Flux. You'll often see it called Flux CD, as in continuous delivery. And the idea is simple. It's just that implementation of GitOps. It's the actual tooling and the actual implementation of that into something that actually works on Kubernetes. So, the way this works is when you install Flux on your Kubernetes cluster, you give it a couple different inputs, but one of those inputs is you point it towards a Git repo. Whether that's on GitHub or your own private tooling, it doesn't matter, right? As long as there's line of sight there. And so this Flux operator that then sits there in Kubernetes, it basically just pulls that Git repository. and it watches for changes. And as changes happen in the Git repository, it'll do a git pull that code. And again, let's just suppose that all of that code is a bunch of YAML files, pulls that code down to the cluster, and then it just kind of crawls through it, through the folders and through some of the mechanisms there, and executes all those YAML files against your Kubernetes cluster. And so you can start to imagine how useful that would be in doing everything from, for example, installing your ingress suite. You know, if you're using Nginx or you're using something like App Gateway Ingress Controller, if you're using Istio or Service Mesh, right? You can install all of that and manage it through what amounts to the YAML files in this Git repo. But then you can even get that into your own applications, you know, the applications that your organization may be building, the development teams that you're working with that need to deploy their apps to the cluster. So you can do all of that with Flux and GitOps in general. So we'll take a look at some of that in real life here in just a second. You know, this is just a quick outline of kind of the workflow here, right? I mean, we're saying developers here. I mean, that can really be developers. It can be ops folks. It can be anybody that is affecting change or affecting configuration on your cluster. In this case, if we're developers, right? I am a developer, right? So as I build my application, there's undoubtedly a CI pipeline, you know, Azure pipelines or GitHub Action or something, that when I check in code into my, and we'll call this a separate repository for now, you know, my actual code repository, I'm going to trigger an automatic build of that. That's going to get compiled. It's going to get put into a Docker container. That Docker container image is going to get shipped off to my registry, and off we go, right? And then we're going to do some pull requests against the actual application, against the actual YAML files that deploy that, right? And so those changes are going to go against my Flux repo. And they're, you know, they could be as simple as changing the tag identifier for the image. They could be complex and have a bunch of configuration in there. But the workflow, again, is that I'm going to make changes against a Git repo that my Flux controller is looking at from my Kubernetes cluster. And so when I check all that in, it goes through all my pull requests and so on and so forth. And then when that all gets checked into my master branch, again, Flux is going to pull that down. It's going to go execute those changes. It's, you know, for example, it's going to say, hey, application XYZ, I want you to be running, you know, this container with the tag of v1.1 instead of 1.0. And that'll kick that down and pull down the image and install it, and off you go. All right, so that kind of is just portrayed here. You know, this is kind of the CD part of it, and that's why Flux is kind of refers to itself as a continuous delivery mechanism.
I'm going to make.
It really takes away the need to do
what kind of image is built
pipelining for your actual deployment into
we talk about.
It takes care of all that for you. Seamless, pretty easy. From experience, it really does make life a lot easier for your developers and your operations folks once you have it up and running. One of the benefits of Flux CD that we probably won't really get into today, but I can have multiple ones of these running, right? So a typical example is I may, as the owner of the cluster, maybe I'm the SRE team or something like that, I may layer in one level of GitOps and Flux for the overall cluster. And one of the things that can do is it can deploy namespace X and namespace Y, or in this case, team 1, right? And then within team 1, I can deploy another Flux configuration that looks at another Git repo, and that repo is owned by team 1, and perhaps that's a bunch of developers. And so you can imagine, and kind of we call this multi-tenancy, I may have 100 different namespaces, each one that points to a different Git repo, each one owned by a different team within my organization, and we can all live as one big happy family that way. So that's kind of the GitOps overview and some information on Flux. Let me kind of show you, and this isn't super exciting, and that's part of the point, right? I mean, we make it pretty easy to kind of come in here and do that. So I'm kind of picking up where Jordan left off. I'm within the Azure portal here. I'm looking at my Azure Arc enabled Kubernetes clusters. So I've got 3 of those sitting out there. We'll just kind of use this one here. So you saw this in Jordan's views earlier. I've got, everything from just some information there. Let me make that slightly smaller, just hopefully you guys can still see that. But one of the things I've got over here on this sidebar is I've got configurations. And when I come over here, you can see I have a cluster, and just to kind of show you this, so this is a command prompt that's touching or pointed at my cluster. I can show you which namespaces I have, right? So I've got my Azure Arc and default, and then just my traditional kube namespaces. What I want to do here is I'm going to come here and add a configuration. And you can kind of see, I'm just going to throw something in here. So I'm naming the configuration itself. That's just an internal naming thing. Operator instance name. And then I'm going to put this inside of the operator instance namespace. So eventually over on this screen, we're going to see that pop up. And then we got to point it to a URL. In this case, I'm going to point it to one of the samples that we have out there for Azure. It is, I've got it here just to show you real quick. This is just a simple Kubernetes, a Flux-based cluster. You'll see that it's got a couple things, like it does have an app that it's going to install here. It's got a couple namespaces. So ideally, if this all works right, we're going to start to see a couple new namespaces show up in our cluster. And within Team A, we're actually going to add some endpoints. That doesn't have a lot to do with what we're looking at today, but you get the idea, right? So we're going to go ahead and set that as a cluster scope. So I can either do namespace or cluster scope. That has to do with that multi-tenancy that we talked about. And we can hit go there, right? So you'll kind of start to see that that's pending. And this, it's not instantaneous. It'll take a couple seconds here. But if I, for example, just do ns watch, and we kind of watch that, you'll notice here in just a minute, and hopefully it doesn't take too long. I know we don't have all day, so there we go. So we just popped in the cluster config, which is the name of the namespace that I put in there. And so at this point, now I've essentially installed Flux on the cluster, and it's now beginning to pull the GitOps name repo. Sorry, right? So you can see that it, by effect, it has pulled down the repos. It's it crawled through all those YAML files. It's executed a couple of those, including a couple of YAML files that created those namespaces. And try it again. So now if I look at my services, you'll notice this is that Azure voting one that we kind of talked about. And if I go grab that URL and we try and run that, oh, that's not the right one. Try this again. There we go. So now we have an app running on our cluster. Not very exciting app, but it does work. And off we go. So, that's kind of the idea here. If I wanted to, I could go back into my cluster at this point. I'm sorry, into my repo. Geez, got to get my tongue working right here today. I can come back into my repo and I could make changes here. I could add more applications. I could add more namespaces, and automatically those would then just get would just start showing up here in the clusters. So that is, in a nutshell, one of the features of Azure Arc, but also more generally just a feature of GitOps in general that we can use to really simplify our lives from a DevOps standpoint for our Kubernetes clusters. So that is a big part of how Arc works under the covers to kind of deliver all this functionality. All right, Jordan, back to you.
Thanks, Chris. I'm gonna show the screen again. Let me know, Chris, let me know when you see my screen here.
Yep, you're good.
Okay, cool. So next on the slide deck, instead of showing you really just slides, I'm going to show you how to do this in the portal. So one of the other features that you get with Azure Arc is the ability to apply policies and governance to your clusters. So an example that Chris was showing, he had a couple clusters that were Arc enabled. I have a cluster here that's Arc enabled. So say though that I wanted to pull in 50 clusters or 100 clusters, and instead of, I'd have to go maybe to each one of those clusters, go to the configuration. Obviously, I would automate that somehow. But we have also another way to do that within Azure with what we call Azure policies. So this is the Azure portal. If you're familiar with it, Chris was in it just a minute ago. In Azure, we have this concept of what they call a resource group. So every resource that you create in Azure has to belong to a resource group. And there's a couple of things just on the Azure hierarchy. We have what we call subscriptions, and then under subscriptions, we have resource groups. So there can be different rights and access set at the subscription level. There can be policies set at the subscription level. There can be policies and access also granted from the resource group level. So what we can do in this case around the GitOps, for an example, there's lots of different policies that we can assign. But I'll just show you one to say, hey, we have 50 clusters. How do I want to get this one, say, cluster config, which has, like Chris said, the service mesh, ingress controllers, namespaces, RBAC, all of that deployed to the cluster. But I don't want to even have to write Terraform to do that. I want to maybe handle that just with policy. So what we would do is we would come in and we would go to assignments, and we would say assign policy, and we would build this, we would find this pre-built policy that we have called deploy GitOps to Kubernetes clusters. And this is going to look very similar to what Chris just showed, but so for example, here is the scope, and this is why I mentioned resource groups and subscriptions, but this is scoped to a resource group. This is going to use this deploy GitOps to Kubernetes cluster policy. I'm then going to actually configure this policy. So now this looks exactly like the GitOps section that Chris just walked through. So I would, put in, sorry, I should have had this. I'm going to copy and paste this now. I should have had this already copy and pasted, but this is the operator instance name that Chris was showing. This is the namespace it's going to live in. This is the scope, cluster namespace. We'll just do cluster for this. This is the operator type. Today, like Chris mentioned, we support Flux. Maybe in future releases or updates of Azure Arc, there will be possibly other operators that we'll support. Then you can give it parameters if you want, and then we'll also pass in, I'll just grab this URL to forget here. And then this is where you can enable if you want to deploy via Helm charts. And then this is the current Helm chart that we use to deploy the Flux operator down to the Kubernetes cluster. So we hit next, and then we hit next and review and create. And I can just do that real quick if we want here. I might already have a cluster assigned, already have a policy assigned there. So then what would happen is every time you onboarded a cluster and it went into this resource group, So like this, for example, and this one was actually an example of this. It would automatically say, oh, hey, I have a policy here. It looks like you have a configuration. I need to apply that configuration to these 50 clusters. And so all you have to do is onboard those clusters into Azure Arc. And within, there's a policy process that runs every so often. As soon as that policy process kicks in, it would say, oh, here's my configuration, and deploy it to those 50 clusters. So you don't even have to write the automation to do all of that. And then if you come in, again, this is what Chris was looking at. You can see that this actually, I did this a few days ago because the cluster, the policy config doesn't run every like couple minutes. It runs like every, I don't know, 20. But this actually is inherited from a policy instead of actually a configuration where I went in and configured this. There's another interesting thing here too, where, so what do you do about existing Azure Arc enabled clusters that you don't have in here that that hadn't maybe that were there before you created the policy? And we can do what we call remediation tasks. So we can actually go in and remediate any clusters that were there that hadn't received the policy after it was created, or after it was created. So there's that. And then let me just show you here. You can see that I have I actually have the same policy built, so this doesn't really make sense. But in this example, you can see I have this policy here, and it's compliant. So if I had any clusters that were not, that this policy didn't actually apply to, or maybe there's a new cluster, I would see that this wouldn't be 100% compliant. And then eventually, once the policy engine ran, it would push that configuration, and then you would see this go to compliance. So this is where you can monitor all your policies, and if your compliance, do remediations, define new policies, set new policies for the cluster, like what registry they should use, what registry they can't use, what other, lots of other policies that we have inside of Kubernetes and Azure Arc for Kubernetes. So Chris, I'll hand that back to you to, I think, chat about the monitoring piece. So.
Sorry, get off mute here. Can you see my screen? Get it?
Sorry, yes, yeah, I can see it.
Okay, good. Yeah, so I know we're running short on time here. Just for the last couple of minutes, I kind of want to highlight one of the final big features of Azure Arc, and that is around monitoring. And within Kubernetes, let's say if you're running native Azure Kubernetes services or AKS, we've built a bunch of tooling called Container Insights or Cluster Insights, right? And the idea is that a lot of customers, and rightly so, they want to live within, say, the Prometheus and Grafana stack. But if you're in Azure and you're committed to Azure, we've built what we think is probably a better solution than that. And we kind of just bubble that under Container Insights, right? And so the idea that if you're running native Kubernetes, or I'm sorry, running AKS natively in Azure, you get all that for free. You can, at the click of a button, you can install it and run it in your clusters. But then we start talking about, well, what happens if you don't run your clusters in Kubernetes, but you still want to take advantage of that through Arc? Right. So one of the features within Azure Arc is that we can come over here to monitoring. And I've already set this up. If I were doing this greenfield here, I will show you. And some of this is a little still preview features. So to actually make this work, I have to kind of go through some steps here. I have to make sure I've created a landing spot for all of my telemetry and logging. So I got to create what we call an Azure Log Analytics workspace. I've got to download a script. So this is an Arc specific script that I'm ultimately going to execute against my Kubernetes cluster. I've got to set a couple variables, and then ultimately I'm just going to execute this script. So a little bit of a manual step there to get my Arc cluster wired up to Azure Monitor. But once I do that, it starts to enable all these features. And within Container Insights, you can start to see that, among other things, I get a cluster view, I get a nodes view. So it can see the 3 different nodes and what they're doing. So I'm getting cluster level or node level infrastructure telemetry. I'm down in the containers tab, controllers tab, I can start to see information about the individual controllers. And just make that slightly smaller. Hopefully you can see all that still. You get the idea that I've got a nice view of all my monitoring. And then I can get down into kind of the pod or the container level. I can start to see, my memory. I can see CPU usage. I get nice dashboarding and graphing there. Within Azure Monitor, which is kind of the overarching umbrella of everything monitoring within Azure, I can do things like set alerts. So I could even wire this up to say, hey, if I have a pod that gets evicted because of a request or a limit, meaning it's hogging too many resources, I want you to page me or send me a text or call me or whatever, right? So I can do all that through the umbrella that is Azure Monitor. But the point is that I've now been able to do all that, enable that, all on a cluster that presumably could be running in AWS or GCP. And that's pretty cool. That gives me a lot of options, especially if I'm a large organization that has a multi-cloud implementation, or if I'm obviously hybrid on-prem and Azure. I can treat all of my clusters the same way. So, not really going to dive into all the metrics here just because we're more or less out of time, but that is one of those things I can enable there. You can see I've got logs, and I can do a bunch of that as well. So that should be a pretty good overview of Azure Arc and some of the features that it brings to the table, some of the use cases for it, why it may be attractive to you, but certainly glad we got to talk about it with you.
Yeah.
Ron, Jordan, any last thoughts here? No, we got probably 1 minute left, but
Chris, I have one final slide on takeaways, so I'm just going to steal
okay,
this.
perfect.
So I guess the takeaways.